Something is giving a light pollution.
You're alive. You're alive.
So, yeah, don't point out the telescope.
Hmm? I'm not doing. Oh,
Yeah.
Was it? Okay, sorry.
There we are.
I was just going to use it for the list.
Yeah, just point it out the list then.
Okay. Well, when we need it, yeah. Okay. Are we live?
Yeah.
Okay. Well, good evening, everybody. This is Doug, and Vivek is here next to me, coming to you live from Curiosity Peak, and we are going to take a tour of the Milky Way tonight. Visit some nebulae, which there are more than one kind of nebulae, and we hope you enjoy it. So we're a little bit early, so if you want to chat and let us know you're listening, watching, that would be cool. We're a little early. We're scheduled to start at 9:30, but we decided to get things ready.
Just a welcoming party right now.
Yeah, we're just kind of like housewarming. But it's really beautiful up here. The comet is behind us. I know people have been watching the comet, and you don't really have a good shot of it from where we've got our scopes set up, but encourage everyone to get out with the binoculars and take a look. It's really an easy object to observe with binoculars. You can see it with your naked eye. It's just below the Big Dipper, and kind of about halfway to the horizon from the bottom of the Big Dipper, I would say. Yeah.
Yeah.
So
it's there, all right.
Yeah. It does help if you're in a darker sky. I guess people are flocking up to Julian.
Now that it's higher, yeah.
Mm-hmm.
You need a dark sky really helps.
Yeah, yeah. But you can probably see it from suburbia, maybe even in the city. It look like a fuzzy star, but when you look at it through the binoculars, you see it's got a big tail that's split in two, I believe.
Yeah.
Yeah.
You got your ion tail and you got your regular tail, which is what you can see in the naked eye, and it's basically yellowish white. But with long exposure photographs, you can see the blue-green ion tail, and that's from the carbon.
Yeah. So if you with the binoculars, I don't know if you'll be able to see the blue-green, but
yeah, you can.
Yeah, but in photographs it shows up. That's carbon.
Yeah.
So we're looking at our first image already?
Yeah, this is M20, the Trifid Nebula.
So are people out there gonna be able to see it?
Yeah. I'm just gonna wait for it to stack more, then I'll start describing it.
Okay.
When we officially start.
Yeah, we're gonna be starting out in Sagittarius, which is where the center of our galaxy is located.
Yeah.
Which means that when you look at Sagittarius, you're looking into the galaxy towards the center of it. So it's a lot milkier, a lot more stars. It's brighter. That's the brightest part of the Milky Way, and it's kind of like whatever is behind that area we don't know very well, because the Milky Way kind of blocks our view beyond the galaxy when we look right at the middle. So when we look away from the center, that's when we don't see so many stars in our own galaxy, and we can see other galaxies. All
Let's
right.
keep.
Well, gee, I see something there on the screen, some color.
Yeah, I'm just trying to see if I can up the saturation, but I don't think I can. But it's a pretty good image of the M20.
If you're out there, you can just type in a hello on the chat. Let us know you're there. It's always fun to know who's out there. We can't see you, and you can hear us, but we don't have two-way sound.
Yeah. Camera's cooled.
Uh-huh.
Yeah.
Well, that's a nice image.
Pretty similar to the one that from last Star Party.
Mm-hmm.
Yeah.
Oh, did we look at the trip in the last one?
Well, no, after the Star Party, when it got bigger, when it got
okay.
larger,
Oh,
got more above the horizon. Yeah.
Yeah, it's higher.
Yeah.
Higher,
We got one concurrent viewer. Yeah, we're just gonna wait a few more minutes.
Well, hey, first viewer, welcome, whoever you are. We got about 3 minutes till we are officially on our way. Don't want to leave anybody behind. Oh, shall we? We need to change that 15914 because I looked that up and it definitely was a galaxy. So I would imagine if you slew to it, it'll be a galaxy somewhere.
Okay, which one is it then?
Well, what was it you thought it was? 'Cause that wasn't the bubble, man.
It's 6914.
Oh, 6.
Yeah. Correct that. Let me go back to M20 though. Okay. There we are. It's over here. There's a lot of objects there.
Mm-hmm.
Still got one viewer. Yeah. 2 more minutes.
Okay.
That's the target for. That's one of the targets for tonight.
Oh, that you're doing
right now because I have no other options. But look at the
what, the guiding? Wow. Yeah. Did you buy a new mount?
well, I expect this out of this mount.
Mm-hmm.
Yeah.
Pretty darn good.
HFR is pretty. It's 2.4. That's pretty good. So.
Yeah.
All right.
No.
Bye. We got 3 viewers. Yeah, people are filing in.
All right. Welcome. Welcome.
M20, the Trifid Nebula. We'll get started in probably in just like a minute.
Yeah. Anybody who's listening right now, if you want to just type in hello and where you're viewing from, that would be nice. You don't have to, but we're curious.
Need sign of life.
Yeah. We're out here on the top of a hill with the sky all around us, and
Here we are.
yeah. What's that?
First chat message.
Oh, okay. Oh, it's Kathy. Hey, Kathy. Good to hear from you. You're our major connection in the city.
What's up? It's down to 0.23.
Yeah, hi. Yeah, Kathy's an active IDA member and a real friend of
Okay.
Julian Dark Sky Network.
It's 9:30. Maybe I'll give it like 1 more minute and then we'll start.
Okay. And we're hoping to reach a lot more people in the city, especially younger folks, because we know a lot of people don't have an opportunity to see the real natural dark sky and the Milky Way and all kinds of things that are going on, the comet right now. So we're trying to bring dark sky to you if you can't come to the dark sky.
I have a feeling that number isn't reliable.
Which number?
That one. So I'm going to check directly. Six watching actually.
Okay, well it's 9:31.
Oh, no. Okay.
So as I was saying, we're going to start out tonight in Sagittarius, which is where the center of our galaxy is. That's why it's the brightest part of the Milky Way that we can see. And there's lots of cool things around Sagittarius.
Yeah. So what we're looking at right now is Messier 20, which is the Trifid Nebula, and that's because you have these 3 dust lanes that are basically form like a triangle, so it's called the Trifid. And why we picked this object because tonight we're gonna look at a lot of nebulae, and particularly the types of nebulae. So we have if you see the reddish part, that is the emission, the hydrogen emission from the nebula, which is emission nebula. Then you have the bluish part, which is actually a reflection of the starlight of the stars within it. It's reflecting that starlight, so it appears blue. And then you have another type of nebula called a dark nebula, and that's what you see around, which is these dark dust lanes and these dark cloudy patches around. So this is one of the only objects that has all three types at once and is clearly visible. So that's where we're going to start tonight.
Okay, and by the way, nebula means cloud, and just like we got clouds around the Earth, there are clouds out in space.
Yeah.
So maybe you could say something about what they're composed of?
So, like, if you look at the red is from a specific line that hydrogen emits. So we know that due to that appearance, that part of the nebula is mostly full of hydrogen, and hydrogen is the most common element in the universe. So, and then the reflection nebula, that's mostly just dust. That's mostly dust that's scattering away the starlight. And the dark nebula is much more concentrated, much more dust containing various things from the metals, a lot of metals, other elements, and so all of those are part of the building blocks of planets and other bodies.
So why is the reflection nebulae are often blue?
Because this is a star-forming region, the stars within are mostly young, and younger stars tend to be more blue because they tend to be more hot. So a lot of the time, reflection nebulae are blue, but that's not always the case. It really depends on what the source of the reflection is.
Mm-hmm.
So actually tonight we're going to look at a reflection nebula that's yellow because the star that it's reflecting is more of a yellow-orange color.
Mm-hmm. Okay, and we got Fred Delgado. Hi, Fred. And Rena Cuajo and Seneca Sunbeam from Cuyamaca Woods. Okay, cool. Welcome aboard, everybody. And Kathy want to know if we can see the comet. We can, yes. Okay, Jerry, hello.
Yeah, we can see the comet from here, but we can't. Unfortunately, we cannot observe it with the telescope because
we got some obstructions.
We got the observatory.
Yeah.
Observatory
right.
itself. Yeah.
But come on up to Julian with a pair of binoculars, and it's quite easy to see.
Or you can even try at home.
Yeah.
If you're in dark skies already.
Just look to the northwest from below the Big Dipper, and now about halfway down to the horizon.
Yeah. I think I can show that on stereo.
Okay.
Let me.
Yeah, we're actually going to show you with our online planetarium here.
Quite low right now, but
it's low.
Yeah, it's right over there.
Uh-huh.
It's low to the northwest. It's below the Big Dipper.
Yeah, it's not going to be in the sky too much longer. It's going down, but tomorrow is another night. Okay, so yeah.
Yeah. Okay. Yeah, let's start. So, I think, are we ready to move on?
Yeah, okay. That's Fred's brother.
Okay.
Rena Cuajo. Okay.
Let's move on.
Yeah, let's move on. We got a list here. We're making several stops on our way through the Milky Way.
Messier 8, Laguna Nebula.
Okay, we're going to go to Messier 8. Okay, and just a little side note, Messier was a French astronomer of the 18th century who was hunting comets, and he made a list of fuzzy objects in the sky that weren't comets. He saw they didn't move through the sky, so he knew they weren't comets, and he wanted to, be able to discount them and not confuse them with comets. But his list has been around for almost 300 years, and it's a good basic list of interesting deep sky objects. both mostly objects in the Milky Way, but also some galaxies. He didn't know that they were galaxies at the time because there weren't telescopes yet that were powerful enough to make out the spiral structure. Actually, and also people weren't know whether the universe extended beyond the Milky Way.
Yeah.
But we still refer to those 110 objects by their M designation. So that's M8 is the what?
M8's Lagoon Nebula.
Lagoon Nebula.
It's a emission nebula. Okay, it looks like our capture software is crashing.
Uh-oh.
Let me close it.
Okay.
Bye. Have
We're
fun.
going to restart some software here to be able to capture an image of the Lagoon Nebula. One thing about astrophotography is it's not infallible.
Yeah. We gotta try whatever. Okay, let's see if we can start it up yet.
Okay.
Detecting cameras. I think maybe we got a camera disconnection, that's why it crashed.
Oh, really? Uh-oh. Okay.
Oh yeah, I got pulled out.
Oh.
We're gonna stay for, yeah. Technical difficulties, the cable got pulled.
Okay, give us a minute here. We had a cable snag.
We got it back.
Okay.
Our camera back, and we have, yeah, there it is already. Let me just, cooler is on. Let's see.
Okay, now this object is not too far away from the Trifid Nebula. They're both in Sagittarius.
There it is.
Okay, we're starting to see it.
All right, let's start stacking.
Okay, the image is going to get better because what's happening is the camera's taking multiple images and it's going to combine them. It does look like it's getting better.
Let's get this out of the way. Okay, there we are.
So this astrophotography thing is very addictive. You can start out with just a camera and a lens on a tripod, start taking pictures of the night sky, even a few seconds, get obviously to a dark place, and you will be amazed at things that jump out, especially the Milky Way. These images are being taken through a 12-inch Dobsonian telescope, which is fairly portable. Collapses and you set it
Depends
up.
on your definition of portable.
Yeah, right. You can't put it in your back pocket, that's for sure.
Yeah. Let me get the stretching just right. So the lagoon is just it's an emission nebula, and so a lot of its light is from hydrogen and oxygen atoms. So what you have here is the red you can see is from hydrogen. It's emitted by the hydrogen nebula, and the blue is emitted from the oxygen. So that's what greenish blue. And that's what you see in the nebula. So most of the time the oxygen is concentrated in the core of the nebula, while the hydrogen is usually in the outer parts of the nebula or in dense regions. So that's what you can see in the center of the Messier. And this nebula extends way bigger than the field of view that we're currently seeing, but we have a pretty close-up view of the nebula right now.
Mm-hmm. So that's ionized gas when you have an emission nebula.
The gas has been ionized, and so that's the result of what we get here.
Okay, Christopher Sebald. Hello, Christopher. Tell us where you are. We always like to know where people are hanging out.
Yeah.
So anybody have any questions about Lagoon Nebula? Like there's a dark area that seems to...
Yeah, that's a dark nebula.
Mm-hmm.
So you got the dark nebula present in a lot of objects, so you can see it right here as a dust line across the nebula. Mm-hmm. And there's there's various pockets of dark nebula, and some of them are called Bok globules, and that's where you have stars that are forming. Like the matter that appears dark, it's slowly being taken by it's slowly being contracted by gravity into a star system. Yeah, I guess we can move on very soon.
Okay. And okay, one last thing. Can we see the Lagoon Nebula with binoculars?
Yes, definitely.
Okay.
Same with M20. Same
Uh-huh.
with the Trifid Nebula.
Yeah.
I think. Let me see.
Won't quite have as much detail, but you can spot it, which is a lot of fun.
Yeah, like maybe like. These two are the only objects that'll be visible with binoculars. These are the only two. The rest of our list for tonight is gonna be mostly telescopic.
Right, deep sky.
Yeah, we're gonna go deep.
Okay, yeah. Rennick wanted to know, are the dark areas empty of gas?
Okay, so the dark areas are not gas. It is actually dust that is obstructing. So it's basically opaque dust that is obstructing the background light. So that's what you see, and that's called a dark nebula, and that's what you saw when we went to when we were in M20. All of that Trifid Nebula, those three dust lanes, that's just opaque matter. And what we have in here, we have these things called Bok globules, and these are just globules of very opaque matter, and that is why it looks dark. But it's actually some places where you can have star formation, where you have that opaque matter collapsing in.
So the stars that are in that dark area, those are in the foreground?
Yes.
Okay, so we're not seeing them through the nebula. They're actually in between us and the nebula.
In fact, then our next target will be actually just a dark nebula by itself, and we hopefully might be able to see some stars through it.
Okay, we're going into the heart of darkness.
Okay, you're gonna have to read out the coordinates.
The coordinates? Okay, well you took the light.
Let me get ready.
Okay, well I can use my phone to light it up, I guess. Okay, the coordinates, this is for B68?
Yeah.
Okay, the coordinates are 7.
I need to get that R index going.
Oh, Christopher is in Borrego Springs, all right. Oh, my nephew Clay. Hey, Clay, from out in the Philippines. Been hanging out there for months, waiting for the world to settle down. But hey,
yeah.
Okay, all right. Okay, coordinates. RA is 17 hours, 23 minutes, 55 seconds.
Yeah.
Okay, and the declination is minus 23 degrees, 50 minutes, 41 seconds. Okay, we're moving on. I just read off the coordinates of our next destination.
So our telescope can go there. Okay, I should stop the live stacking.
Huh?
I should stop the live stacking here.
Oh, okay.
We don't want to stack images that don't exist. Let's see if we got it here. I think we might.
Okay, yeah.
It's going to take a while to load though.
Okay, so this is a dark nebula.
Yeah.
So see if you can figure out where it is.
It's going to slowly appear.
A clue, there'll be an absence of stars in that area.
Okay, here we go. Okay. Starting to stack.
So this is live camera stacking right now. The camera's taking pictures, and the software is stacking them up, and so that really enhances the images when we stack them.
Yeah, here we go. It's starting to stack.
Oh yeah,
now.
We're seeing a lot more stars, except for one area. Is that it right there?
Oh, actually, we have a system here.
Oh, we got more than one dark nebula.
Yeah, it's just an area with a bunch of dark nebula all around it. And that's, where are we looking right now?
Okay, so there's multiple, I said there was one. There are multiple dark nebulae in this.
It's also called the ink spot nebula.
Yeah, the ink spot. Okay, there's, yeah, you're showing where the ink spot is.
I don't think. Okay, let's like. Yeah, I think. Yeah, here we go. Yeah. I don't think we land around B68. I think we just are in the general region.
Okay.
But we
yeah.
still have the dark nebula. You can start seeing it now.
Yeah. By the way, the software that Vivek's using to show you, a chart, that's free software. It's open source. You can download. It's called Stellarium, and it's pretty useful for astronomy. Shows you where all kinds of objects are.
Let's make it.
Okay. Oh, people in Borrego are watching this on a TV screen, and they just saw the comet in Borrego.
Okay, here's a dark nebula. Hopefully most of you can start seeing it now. There's like a patch over here that goes around here. I think that's called the Snake Nebula.
Uh-huh.
Yeah, we got like three other patches over here. Yeah.
Yeah, the snake.
And that is a dark nebula. That is dust that is blocking the foreground light.
Mm-hmm. Lots of dust out there.
Yeah. If you actually look in the infrared light, these these opaque dust, they start to become transparent because they can transmit longer wavelengths.
Mm-hmm.
Just like how radio waves can get past a lot of our buildings, so we can start. So if we look at as we go higher, if we go higher wavelength, then we can actually look at what's behind it.
What's behind it? Yeah. Okay. Okay. Any questions or comments? No. Don't be shy. And Maganda Umaga. It sounds like Fred speaking Tagalog there.
Okay. I think we can move on soon.
Okay. Next stop on our
NGC's. We're gonna go to
6914 though, right? Oh no, we're going to 688. Okay. NGC, that refers to new general catalog?
Yep.
Yeah. That's a big catalog of 10,000 objects. A little bit bigger than Messier's.
Made in the 19th century.
The NGC?
Yeah, 19th century.
Yeah, so 19th century, Messier was 18th century. He had 110 objects in his catalog. The 19th century NGC catalog has 10,000. So it can keep you pretty busy observing or imaging these other 10,000 objects. And a lot of things have a designation in more than one catalog. Okay,
We're almost there.
Yeah. Okay, Clay says it's 1 p.m. where he is with lots of rain.
Okay.
Okay, so we're going to the Crescent Nebula?
Yeah.
Yeah. So what kind of nebula is the Crescent?
It's actually quite interesting. So let me show where it is really quickly. And it's in the middle of. It's right near Satyr, one of the stars in Cygnus the Swan. And let me.
Mm-hmm. Which is an interesting part of the Milky Way. Huh?
Yeah. Let me see if I can get the live stacking to show it. Let me see. Are we even in the area?
Well, it's not a real bright object, right? It's going to take a little stacking to
Yeah.
bring it out.
But it's usually, I think last time it was showed up very quickly.
Oh,
We might not be there.
okay. Well, might have to redirect the scope a little bit.
Of course. I can pause the light stacking.
Yeah, thank you, Kathy. Yeah, besides letting us know, it lets everybody else know too who you are and where you are. Sometimes the telescope goes rogue a little bit, doesn't point to where we want it to, but
We can handle it.
yeah,
It's just slightly annoying. There it is.
okay,
We got it.
got it.
It's almost.
All right, a
You
little-
see it?
Oh,
Maybe it'll just keep the hand controller here.
okay,
Let's start stacking that.
okay. So we're going to start stacking images now and see what pops out. And it better be crescent shape. Oh yeah,
It's almost there.
it's starting to appear. Oh, there's Fred in New Orleans. Hey, muy bien. We got two Freds with us now. Hey, Fred, your name's misspelled, but that's okay. We'll forgive you. FC Lane. Oh man, another Tagalog speaker. Okay. Okay, can people see that crescent shaping up?
Syracuse, New York.
Wow.
25 viewers.
Okay.
Okay, yeah, so we got it's starting to show up
Okay.
a bit.
Now it looks pink to me.
Yeah, that's from hydrogen.
Okay.
Ah, no, I went that too far. Okay.
Is it only hydrogen?
Not gonna pay money for that. Yeah, there's also some oxygen too, but mostly it's hydrogen dominated. And it's from a type of star called the Wolf-Rayet star. That's basically a very, very hot, massive star that's rotating very quickly and has large amount of wind on its surface. So what it's doing is it's throwing a lot of its gas out. So that's what you're seeing here. You're seeing a Wolf-Rayet bubble that's throwing away its hydrogen gas, its oxygen. It's throwing away all of that gas into the interstellar space. So that's what this type of nebula is. It's an emission nebula, but it's from that type of star.
Okay. It doesn't look like it's throwing anything out. I guess.
Actually, it's this star right here. That's the Wolf-Rayet star. And if you...
All right, we got Makeda Dread with us. All right, Makeda. I wish we had a little reggae accompaniment here with us, but you being here, it's almost like the same thing. So hope you guys enjoy it over there at the World Beach Center. Okay, so for people who just joined in, we're touring the Milky Way tonight. So we're in the constellation Cygnus the Swan. Of course, constellations around the world have different names because people interpret what they see in the skies in their own way and come up with fascinating stories. So, we're kind of settled on some that astronomers use just as a convention because it's convenient but they're just basically kind of divides the sky up into different little territories.
Yeah.
So we know where we can locate things.
I was trying to find a spectrum of that star actually because it's very interesting. So electromagnetic spectrum, it's basically looking at the wavelengths of light at what it's emitting. So I couldn't find it, but basically because of how peculiar this star is, it actually has emission lines, or it strongly emits at places where it's hydrogen gas is emitting, where it's helium, even helium, carbon, oxygen, neon, lots of different elements. So it's a very peculiar type of star, and it's causing this bubble to be formed.
Yeah, one thing, a lot of people assume all stars are more or less the same, but
Yeah,
they're not.
a lot of variety.
Yeah, very diverse universe.
Yeah.
They're all producing energy, fusing some kind of atoms together, but at different stages of their life cycle, they can be fusing hydrogen atoms together, or they run out of hydrogen. Then the next thing will be helium, and so on, until they run out of fusible material, and they collapse, and sometimes throw off gas. They're big stars.
Any way to tell how large the cloud is? Yeah, so basically we have to first find the distance and then compare it to its angular size. So I don't actually know what the calculated size of the crescent nebula is, but the way you'll find that out is basically by looking at that star, that Wolf-Rayet star, measuring its distance to various means such as parallax, which is a method of using how our line of sight changes as we orbit the sun to see how the star shifts. Like if you ever go down a road, if you look out to, like, say you look out, the farther something is, the slower it shifts, while something right in front of you will quickly go past you by. So looking at that type of shift allows us to calculate the distance to many stars, including this star that is emitting this bubble. So if we find out the distance to that star, then we can look at how large it appears in our sky and use that to calculate how large it actually is. And that's that. So the term for how large it is in the sky is called angular size.
That's kind of like parallax, or
how you discover distance using parallax.
yeah, that works for things in the Milky Way.
Yeah, anything that's pretty much like within our Milky Way we can calculate parallax. Anything farther than that, we have to use different means.
Yeah, that was discovered later on, in just the turn of the 19th to 20th century.
In fact, the Greeks, when they had a geocentric view of the universe, because if we were actually going around the sun, they would expect the stars to be shifting. So they didn't see the stars shifting as we go around the sun due to that parallax. So they automatically assumed that we are not orbiting the sun because the stars will be shifting. But it turns out that shift it's just way too small because the stars are very, very far away. And that's what they didn't account for.
Yeah, we thought maybe they were closer.
Yeah.
Okay, so, yeah.
All right, let's go to the next target.
Okay, let's see. We got some more people watching from San Diego. Mark and Donna Turner. Yeah. Okay.
It's time to move on.
Okay, we're moving on to another target. Let's see what's next on our list here. Okay, we're going to NGC 6914.
Yeah. Let me get there.
Now, since there are 10,000 of these NGC objects, some of them we get to kind of familiar with because they're often imaged and very popular, very photogenic. Some other ones, though, like this one, I'm not familiar with it. What is there? Have another name? 6914?
No.
No. 69.
It's just there's other catalog names, but it's not being colloquially named. So if you want to give it a pretty name,
yeah, if
you're welcome to.
Name, right.
You're welcome to do that.
Hey, Vivek has an asteroid named after him.
Not yet.
Not yet? Oh, it's waiting.
Gonna you have to wait like 2 years for that.
Okay.
Unfortunately.
That's what happens if you win the right contest, right?
Get there. I think we're here. Yeah, we're here.
Okay, so
Let me just get us more center.
6914. I'm gonna have to look that up on my phone then.
It's
Or no? Or you're gonna tell me? Or tell us, I should say.
well, yeah. So it's. Let me get the. It's much easier to understand once you have it got stacked.
Okay,
So.
we're waiting for the image to appear.
Okay, let's get it out of the way.
Does your telescope have a nickname?
12-inch Dob. No, it doesn't actually have a name. No.
Dobby? No.
Skywatcher 12-inch go-to Dob.
Yeah, if someone wants to come up with one, we can. Yeah. Not yet, anyway. No nickname yet.
Nope.
Maybe when you get mad at it.
Swear at it. Why are you so bad?
Okay, we got somebody from Puerto Rico. Where's Joe? I'm looking. Oh, Joe LF from Puerto Rico. Fantastic.
Okay, we got stacking now.
Okay, our image is on its way.
Let me get us what we're actually looking at, and it's also right. It's right near it. It's on the other side of Satyr, which is in the constellation of Cygnus the Swan, and it's a very nice set of reflection nebulae. Those are the type of nebulae where it's reflecting starlight. In this case, it's blue, and that's what we're gonna be seeing here.
Okay, a reflection nebula.
Yep.
Yeah. Okay. And Joe, we'd love to know how you heard about this in Puerto Rico.
Think it's very noisy, but you can start to see it. It's these two pair. We've got two pairs. We got a pair of reflection nebulae. There's a third one down here, but it's too faint right now. But it's the type of nebula where we're reflecting starlight, and it might be very hard to see, but if you look in the background, there's some reddish stuff. That is hydrogen that's being emitted from a bunch of hydrogen gas. That's light being emitted from hydrogen gas in the background. So. There's actually some dark nebulae around here too. That's opaque dust that's obstructing starlight. Okay. But right now, we're a bit too noisy to see a lot of that right now. But
so the kind of magenta that's ionized hydrogen gas.
Yeah.
Yeah. Okay. What constellation is that?
Cygnus, the Swan.
Oh, we're in the Swan, Cygnus.
Yeah, we're just kind of a little noisy. It's a pretty faint target. We're being a little ambitious tonight. But I think might be able to see it.
Oh, okay. The guy, Joe LF, is a brother of somebody at the World Beat Center, I guess. Great.
Yeah.
Okay.
Yeah, I think we have a pretty okay image of it right now. Yeah.
Okay, Lynn, welcome. Girl, you overslept, huh? No, your computer issues. Okay. We know signals aren't always strong out there in Pine Hills. Anyway, glad you made it.
Yeah. We got some wind that's messing with the image.
Yeah, so the image is a little shaky.
We do what we can.
Yeah.
Yeah. Anyone?
So we're going to move on, or anybody have any questions about any of the objects we're looking at? Yeah.
I mean, we can move on. Okay, I think we can call it.
Okay.
We're gonna move on.
Hey, Valerie. Hey, how you doing, Valerie? Another local Julian person. Okay, we're going to move on to NGC 6960.
Okay. Let's get going.
Okay.
NGC 6960 is the Western Veil Nebula, or the Witch's Broom Nebula.
Oh, the Veil Nebula. Okay, this is a very interesting one. This is going to be something a little different from anything else we've looked at so far. I'm going to give you a clue. It's a fragment left over from a very powerful process. Okay.
We're almost there.
It's also sometimes referred to as the witch's broom. So see if your imagination aligns with that name.
I think that was it. I just went too far. It's also pretty faint, but we can do it. Yeah, I kind of can see it.
Okay.
That one's 51 Cygni.
Yeah.
That bright star over there.
Okay, right. That's the
I think that's a
tells you you're
good enough framing here. Let's start stacking this.
Okay, so the image is going to start appearing now.
There we are. Get the stacking process going.
By the way, I know people are curious about the comet. Oh, hey, Chip. Good to have you on board. Burning Man Chip. Okay. Yeah. If you're really interested in seeing that comet, get out of the city. Come up to Julian or Pine Valley or somewhere out of the city where the sky is dark, and you will have a much better view of the comet. You got to do that while it's still around because it's going to be getting fainter. Even though it's getting bigger, it's got a big long tail. Okay.
I don't know if people can see that.
Yeah. Well,
It's pretty faint. It's a pretty faint target.
Okay, it's starting to become visible right there. Yeah. Okay, now you see that bright star. Look at to the right of it and up a little bit. It's like, okay. So did you just
There we
stretch?
go. Yeah.
Okay. This is actually a really beautiful object.
Let me get in the planetarium
Which
software.
is why it's called the witch's broom, I guess. Right?
Yeah. This is...
It's a very colorful broom.
Yeah. So we're starting to see it. But this is actually one part of a gigantic 5-degree, like 5 or 6 degree large supernova remnant.
Mm-hmm.
It's called the Veil Nebula. And this is just the western one of the western parts, one of the brighter parts. And this is from a supernova of a star from a very long time ago. And so what we're seeing is a lot of the red is the hydrogen from that dead star, blue is the oxygen. So if we can look around along the supernova remnant, which is actually pretty big, this is an entire remnant. So it's in Cygnus, but it's a very large part. It's plenty of full moons across, probably like 6, probably like 12 or so.
Mm-hmm.
But this is just the western part we're looking at, and this is, yeah, it's the remnant of a supernova.
Okay, everybody knows what a supernova is, I assume?
Well, if you don't, a supernova is when a fairly massive star, when it finally runs out of hydrogen in its core, the core collapses, it rebounds, and then the star basically explodes, and you have the outer parts of the star thrown off into space, which is what this nebula is one part of, while you have while you have that core that collapsed, it can turn into something like a neutron star or a black hole, or a specific type of neutron star called a pulsar.
And it throws off a lot of energy.
Yeah, more than the entire lifetime of the sun.
Wow, yeah. So the sun will never become a supernova.
No, it's not massive enough. It'll turn into something called a planetary nebula, which is what we looked at. We looked at some of them in the last star party.
Yeah. Yeah, the most spectacular supernova in human recent history was, I think, in 1050 something.
Well, you mean the last supernova that was visible to the naked eye?
Yeah, right, to ordinary people without telescopes.
1054. That created a nebula called the Crab Nebula.
Yeah.
But actually, it's not the most recent. After that, we had Kepler supernova and Tycho supernova. Those are two supernovae around 1600s.
Oh.
That were visible to those people. The
really
astronomer Johannes Kepler and Tycho Brahe, they both observed those supernovae.
So were they visible in the daytime?
probably.
Yeah,
They're
because the
pretty
Crab
bright.
Nebula was definitely
Yeah.
seen in.
But
in
the thing is, we can look if with the telescope. You can look at supernova almost any time of the night because you can just look at because there's always some supernova going on in some galaxy.
Yeah.
And sometimes they're even in pretty bright galaxies, such as you can have it in the M81, which is Cigar Galaxy, Messier 81. Recently, we had it in Messier 61, which was pretty exciting. But yeah.
Yeah, of course, those are much farther away, so
Yeah.
you need a telescope to
Yeah,
to
they're pretty
yeah.
faint. You have
Yeah.
to have a telescope.
But if you were in that galaxy, it would be pretty bright.
Yeah, for
Yeah.
sure. Yeah. Well, I think we should. Then we can move on.
Okay.
Let's see. NGC. Okay, yeah, that's.
Okay, we got some dark humor going on here. With whether humans will be around to see the comet again when it returns in 6,000 years. Of course, the comet could be extinct too. You never know. Comets don't, we can somewhat predict them, but,
Yeah.
not entirely.
Yeah. Let's. Let's stop. Live stacking. Yeah, this is a live feed of what's going on right now. The stars, they're just moving around because of the wind.
Oh, okay.
Yeah, it's
Now, is this
pretty.
you just went to a new object?
No, I'm about to go.
Okay.
We're still on the veil.
Oh, okay.
Let's go.
Yeah. So anyway, that Veil Nebula is part of a complex of nebula fragments from a single star.
Yeah, the other parts are called
With
the Eastern Veil, the Pickering's Triangle. They have all sorts of names.
Yeah.
They were on the planetarium
Covers
stuff
a
earlier.
pretty good sized part of the sky, like about 10 times the size of the moon. Our moon. Okay, so we're moving on to NGC 7000.
I don't know if one will see it. I'm not sure if we're.
Well, it looks like the scope moved. Somewhere.
Where are we going now? We're going trying to
7,000, right?
We're trying to locate, and yeah, we're trying to locate that, but it's a pretty large and diffuse nebula.
Oh, okay.
So we're kind of lost in space right now.
Okay, we're searching. We're sending out a search party.
I mean, we
this
could just
nebula.
go on to the next object. This is a
Okay.
little faint.
Yeah, it might be hard to even know when you're there until it.
Yeah, it's way too large. It'll take up the entire
Okay,
screen.
okay. How about 6781?
Yeah, let's go to that instead.
Okay.
Okay, I expected it to show up sooner. Yeah. Our lack of proper go-to right now is being a little troublesome.
Okay.
One cable snack can do that.
Yeah. Okay. Then it becomes know your sky time.
Can't know all of the sky at the same time, though.
Yeah.
Unfortunately. Almost there. This one's pretty visible. Oh, it's right there. And it's gone. It was
Okay,
there
but-
for like 5
but
seconds.
You saw it flash by. Okay, so it shouldn't be too hard to
There it is.
return. Okay.
We're s-
And in case you were wondering, the stars aren't actually multiplying. They're just when they're moving,
Moving.
we get little multiple images. Ooh, I see a fuzzy something there.
It's getting beaten by the wind.
Uh-huh.
Let's start stacking this.
Oh, is that little planetary nebula that you...
Yeah, it's a planetary nebula.
Yeah, okay.
Let's start stacking this.
Well, we've got... Ornithology, birds, yeah, right. We have an ornithologist with us. And that would be... trying to connect the name with the ornithologist.
Yeah, well, we were in Cygnus the Swan.
Yeah, right. That might be what attracted our ornithologist. Okay.
Yeah, this wind is doing a number on
Okay,
it.
well, anyway, you could see some of the color there. And what kind of nebula is that? That's not...
That's a planetary nebula. It's called a snowball.
Okay. Yeah, there it is in vivid color, taken by a major observatory.
Yeah. Yeah.
But we got it.
Yeah.
We captured it. Yeah.
NDC 6781. The
Yeah.
snowball. Yeah.
Kind of a rainbow, isn't it?
Yeah, so that's a typical planetary nebula, because when you have that, so this is from a lower mass star going poof, where you have, and that's because during the end of its lifetime, most of the hydrogen is in the outer part of the star, and there's none in the core. So when it blows off its layers, you're gonna have the hydrogen on the outside.
Which is the red.
Yeah, and that's what you get here. You have the red from hydrogen emitting. And at the center, you mostly have the oxygen because it's mostly present in the core. So that's the anatomy of a planetary nebula.
Okay, Lynn wants to know how far away that nebula is.
Let's consult
Well, it's in the
stellarium.
Milky Way. It's definitely in our galaxy.
That is 2,303 light years away.
Okay, 2,303 light years away. That is not very far in our galaxy, since the galaxy is about, what, 140,000 light years across?
Yeah.
So 2,000 is kind of our neighborhood, yeah. And that's probably a small star, I guess, or
Very recent.
average star,
Yeah.
and a recent...
Because it's not that big right now.
Yeah, yeah. And the reason stars collapse is interesting.
It's because it runs out of hydrogen in its core, so it doesn't have anything to fuse.
So what takes over then?
What it does instead is it starts fusing other elements. It starts going to helium, helium into carbon, carbon to oxygen, and then oxygen to other elements. And at some point, it doesn't have these smaller stars, they don't have enough heat produced to continue that cycle of fusion. So what happens is the core eventually collapses to gravity, and that rebounds, and you have these outer layers blown off into the interstellar space. So it's in some ways similar to a supernova, but what really stops a supernova is it starts losing energy from trying to fuse iron, because when you fuse iron, it takes more energy than you actually get. So that's what eventually stops a star from a massive
star. So it runs
star.
out of energy, yeah.
But in this case, it's just because it's not getting hot enough to continue that cycle. So it stops at carbon.
Right. So the sun, there's our sun, our star. There's two forces that are kind of in balance. Then gravity
and the
the
pressure
energy,
from the
pressure
from the nuclear
yeah,
pressure.
Yeah. So if the gravity gets stronger than the pressure, collapse. Yeah. And then boom. Yeah. That won't happen for a few billion years.
Yeah, 5 billion years away.
But it will happen.
No need to be concerned. We'll be dead.
Yeah.
Those are awesome color for the nebula. Yeah. Probably. A legacy of debris. That is possible. Yeah.
Oh, about
It's
about
not
the
as
comet?
it's not as impressive as the great comets that we've had, like Hale-Bopp, but it's pretty impressive in its own right.
It's the best one I've seen for a while.
Yeah.
Yeah. And
It's the best one I've seen in my lifetime.
yeah, someone's wondering about, will we be plowing through it, the debris left over from, well,
Possible.
yeah, and that's what makes meteor showers. Usually it's the remnants of comets,
Yeah.
and we pass through it, and it's kind of like all these things burn up in the atmosphere as well.
Another thing is if we had like a great comet, sometimes it fragments into pieces, and then when they come back, they turn out to be whole new different comets. That's something that's happened before.
Oh, they've split into
A large comet splits into smaller ones.
Uh-huh.
That's not what's going to happen in Neowise, but that is sometimes that's the thing that does happen.
A big comet, a real mass. But Neowise is like a couple of miles.
Yeah, it's not
across.
that big, but it's
I
so
mean,
it won't undergo that process. Anyways, I think we should move on.
Okay, all right. Yeah, we're not finished.
We got former objects. Okay, let's go to IC 5146. That is the Cocoon Nebula.
Oh, the Cocoon. Okay.
That will need some coordinates though.
Okay, 2153.
Oh, not yet.
Okay.
I need to create.
That's 5146, right?
Yeah.
IC. Okay. What is IC? Is another catalog.
Okay, so they are 21,
53, 24. That's hours, minutes, seconds.
and then
47 plus 47 degrees, 16 minutes, and 1 second.
we're going.
So we're navigating just like you had a chart and you were out in a boat. Okay, if you hear something humming, who is with you? Oh, okay, Valerie wants to know who's doing the talking, the intelligent talking. That's Vivek. He's a young scientist and a student in San Diego, and comes up to Julian to do science projects, astronomy projects, and take pictures, photos. Excuse me. Getting a little cool out here in open air. Broke up in 1994 and smashed into Jupiter. Okay, that
That's
was
Shoemaker
Shoemaker's
Levy.
Right. Yeah. That's always something when you can either witness or photograph something like that, a collision.
Oh, I see it. There we are. Cocoon is right there. It's a
Okay.
pretty impressive object.
Okay, this is a cocoon.
That's actually my first LRGB target.
Mm-hmm. Cocoon Nebula is a pretty object.
We'll see it in a second. Let me turn on light
Almost
stacking.
kind of wine colored.
Let's get it going.
How would you describe the color of the Cocoon Nebula?
Red.
Red, okay. Well, that's
From hydrogen.
That's kind of a simplified version, okay.
Well, it's got a reflection nebula and it's got dark nebula around it. It's got all three types too.
Mm-hmm. But it's not a bright red, it's kind of a...
Well, it's a
has
faint object.
Yeah.
We'll see it soon though.
Mm-hmm. We are definitely outdoors, yes. We're right next to the observatory. We have we call it open door observatory. It's about a 45 by 15 foot outdoor area that's enclosed and kind of, we can drop tarps down and block the wind a little bit and ambient light.
Yeah, we've also got our own setups imaging right now.
Yeah, inside the observatory, our telescopes and cameras are humming away.
Well, mine's outside.
Oh, yours is outside. That's true. Okay. Well, got one going inside, one going outside. Grabbing these.
Well, yours is doing the veil.
Yeah.
Yeah,
You're
this
actually imaging that right now. Yeah. And I'm starting to see the cocoon appearing.
Yeah.
So that's going to get a little more intense.
I don't know. It's pretty faint.
Is that?
We're really trying to stretch the limits here, but I think that's pretty visible there.
Okay, there's the Cocoon Nebula right more or less in the center.
Yeah.
And it's got some dark areas that kind of divide it up.
Yeah, it's got dust lanes.
Dust lanes, yeah, the dust is back.
We have that red. If you can see that red, that's because it's mostly a hydrogen region.
Mm-hmm. And right around it is also, there's dark
Yeah,
dark
this entire portion over here, all of that is dark nebula, but you can't really see it right now because it's pretty hard to see.
Yeah.
But
So the dust is part of what, okay, Lynn wants to know how big the Cocoon Nebula is.
is in the sky or in actuality?
Well, we know both.
I can only
There's
tell.
how big it is actually, and then there's
It's 12 arc minutes in size. I don't know how big it is in actuality, but I mean you could calculate it. But
yeah, there's the apparent size, but then how big it really is depends on it.
probably a few light years.
Whether if we know its distance from us, then we can figure it out,
Yeah.
like the sides of a triangle.
But let me show where it is. We're still in Cygnus. We still haven't left Cygnus. There it is. It's down there.
Yeah.
Okay. Want to move
Well,
on?
then we can get back to you and find out how big it is across.
Okay. NBC 7129. That's a reflection nebula.
Mm-hmm.
So we're gonna head there now. Apparently it's called small cluster. Okay.
Well, we're seeing images that are like taken over a few seconds each, and then stacked. When we're doing serious photography, we take like maybe 5-10 minute images and do those, take them for hours, so we get a lot more out of the images. And I would encourage you to go to our website, curiositypeak.us, and you can see some of the images that we've taken. Vivek, myself, Roy Hansen.
We're plugging ourselves right now.
And Fred Delgado. So
Alright, we're almost there.
also Julian Dark Sky Network .net. You can see images taken both through telescopes as well as just with cameras up here, in like local photographers, amateurs, some kind of professional. Kevin Wixom, for example, including some pictures of the comet.
There we are.
Hey, Donna Turner, glad you were enjoying it.
There we are.
Okay. So which one is this one?
This is NGC 7129, the small cluster nebula. It's a reflection nebula.
Okay.
It's exactly why it's named that. It's because it's reflecting, it's a nebula, it's a bunch of dust that's reflecting the light from its cluster around it. I mean, you can kind of see the fuzziness around the cluster right now.
Yeah, it looks a little bit like the Pleiades kind of.
Yeah, but we need a lot, but right now, the wind is hammering the setup.
The wind is picking up. Yeah, it kind of shakes the telescope a little bit.
It's ignoring 22 frames right now. Every single frame we're taking right now is being ignored.
Oh, okay.
That's why.
Oh, if there ain't too many that are good enough.
It's being ignored. It's not good.
Okay.
We're not getting any good. I should lower the exposure time.
Yeah, that might be a way to get around
Oh
that.
my goodness.
Okay,
There we are.
There we go.
Start getting
That's a little more distinct, yeah. Now, can I change something so I can see you to make it bigger on my screen?
Yeah, can I?
Wait, yeah. Just click on, right down there, okay. I'll still be able to see the chat. Oops,
Yeah.
I think it wiped the chat out.
No, it's because it's full screen.
Okay.
I can just close the screen.
Oh, okay, that's fine.
Yeah. This is hammering our setup.
Yeah.
Oh my goodness.
Well, at least it's not cloudy.
That would be bad.
Yeah. That's Cygnus? In Cygnus?
Okay, my stretching is not good.
Okay, is there maybe some brighter object we can go to?
I don't know if people can see that. There's like a fuzziness, yeah.
Mm-hmm.
It's a bit, yeah. We're losing a lot of frames to the wind.
Yeah, what the software does, it throws out the blurry images, so when the wind's blowing, we don't get as many good ones. How about what do you think about going to a brighter planetary nebula, maybe? Somewhere?
Well, we have ooh, this is a pretty good one.
Okay.
Okay, I think we're gonna be done, but yeah, reflection nebula. But we're gonna move on to another object I have to use coordinates for.
Yeah. Did you sync so the telescope's aiming better?
It's starting to aim better now.
Okay.
It's doing better. I have faith in it.
All right. Good enough for me.
Okay, ready?
Mm-hmm.
Coordinates. 21, 16, 26.
Okay, we're moving on.
And then that's 168, 15, 37.
You got the coordinates?
Yeah.
Okay. Oh, this is the VDB.
This is the Ghost Nebula. It's a yellow reflection nebula.
Really? Yellow, yeah, that's not so common.
No.
There's a bright yellow star or something flashed by. Red star.
I think it's this. Let's look at the Ghost Nebula. Yep, that's it right there.
Okay.
It's gonna... This is, I guess, reckon this one's also very faint. Just getting all the faint objects here.
Okay, we're kind of pushing the envelope here, going for some faint things.
Yeah. Start stacking. I know.
That looks like the one we just looked at.
I know.
Oh, okay.
I have to clear it.
Okay.
There's a professional observatory picture.
Mm-hmm.
We have Cepheus. Constellation Cepheus. In the north.
The king, right? Cepheus?
Yeah, it's a king. Very kingly.
Okay, we're in a new constellation, Cepheus. And this is has both emission and reflection.
No, it is just a yellow reflection nebula.
Oh, this one's a yellow reflection.
It might be a little faint though.
So it's from a nearby yellow star. The light.
This one right there, that yellow star.
Mm-hmm.
It's gonna take a while. We're only 13 seconds of exposure, so we're not even close enough. I think it's showing up now.
Yeah, I see something there.
There we go. Start. Let the frame roll in.
Okay, yeah, it's kind of to the left of center. There's a fairly bright star, but you notice some fuzziness around it. That's the nebula.
Yeah. You can start to see the shape. Yeah.
Now someone's probably wondering, is the sky purple in Julian?
Nah, it's just the color balance of the camera.
Okay.
The changes are on the sky based on the gradients. Yeah.
Well, I see Jupiter's up there fairly high. Well, we'd need to have a Barlow to get a very good look at it.
Yeah. Okay, I think that's probably the best we're gonna get out of this in the wind.
Okay, what about going to, say, the Ring Nebula or the dumbbell? It's not on the list, but I was just thinking it's bright, you know, and
Yeah, we can end on that because we're getting late now.
yeah. Okay.
We
So,
could try the bubble.
the what?
The bubble.
The bubble. Okay.
That's a pretty good object.
Okay, so that we're going to Cassiopeia.
Yeah.
Cassiopeia is the queen.
Yes, it's 100 degrees rotated because it's based on how we rotated the camera.
Mm-hmm.
In the, yeah.
Okay, Chip wants to know, is the telescope image 180 degrees rotated from the chart image? That's certainly a possibility.
I know this one's pretty bright, so we're gonna have a better luck here.
Okay, what are we going to?
Bubble Nebula.
Bubble Nebula, okay.
It's bright. It's already showing up.
And there's a nice star cluster near it, too.
Yeah, unfortunately that won't show up on the screen, though. Let's get light stacking on that. That is over here.
Okay.
It's named that because there is a bubble there.
Yeah. It looks like a sphere. It really looks like a shiny marble or something. Yep, there it is right in the center. Okay, we're starting to see it.
Yeah. Yeah, it's showing up. That's good. Let me zoom in on that.
Okay.
Yeah, that's too much
Yeah, a
zoom.
little too much, yeah.
That's just right.
Okay.
Yeah, you can start to see this feature over here. That's a structure inside of that bubble nebula. It's the brightest part of it.
Mm-hmm.
You can start to see that edge of the bubble.
Yeah, it's really a sphere.
It's only a 10-second exposure. We're 10 seconds worth of exposures right now. 12. Yeah, we'll let it stack.
So did you hear the question that Chip asked about the telescope image?
Yeah.
Is it 180
Yes,
degrees?
because
Yeah.
it depends on how we rotated the camera.
Yeah.
Well, it's there.
Okay, there's the bubble. Yeah. Well, there's more. You can see kind of half the bubble, right?
There's an entire nebula over here. We're just
Yeah.
seeing the brightest parts of it. Yeah. So you want to end on the dumbbell or ring?
The ring would, I guess, which one would be?
Probably M20. I think dumbbell would be the largest, so yeah, we
Okay.
can end on that. Yeah.
Okay, we looked at the dumbbell nebula last month. We're gonna take another peek at it to make sure it's still there. And for people who weren't on board last week, this is a planetary nebula. It's a somewhat large one, and it's got all kinds of interesting details in it and colors, which do more exposures, processing, and so on. All those interesting features and colors jump out. The reason that it's a complicated process is because we're looking at things that we're not getting a whole lot of light. They're faint things, so it requires long series of exposures and working the resulting image to bring things out.
There it is.
There it is. There's the dumbbell, and you can see
this one's a very bright object.
Yeah, it's pretty bright. Yeah, and you can see some of the color there. And we just there right now. So we're gonna stack a few images and
We'll be on our way.
yeah.
Let me clear the last one.
Okay, so this is our last stop of the night. If anybody's got questions, comments, suggestions, anything like that, we are all ears and eyes, and we appreciate everybody's participation.
Don't forget, that star over there, that has an exoplanet.
Oh, okay. What's the name of that star?
It's HD 189733, has a catalog name. Yeah.
Wow. Okay.
But it's got an exoplanet, one of the
Uh-huh.
most easily observable exoplanets.
Yeah, everybody knows what we're talking about. Exoplanets are planets that go not around our sun, but around other stars. And amateur astronomers are doing work to help facilitate the work of professional astronomers, and that's called citizen science. So, I got to image a star the other day and see the variation in its brightness, which was caused by an exoplanet transiting in front of it.
Yeah.
And
you can even do that work with the camera, lens, and a tracker.
really, without even a
With
telescope.
DSLR. Yeah, don't even need a telescope.
Yeah, so lots of work to do out there in the field of astronomy. Wow, that's not a bad image. Look at that red and blue. Yeah.
Same
okay.
thing where you have most of the hydrogen is in the outer parts.
Yeah.
Because that's where it was in the star.
Mm-hmm. Yeah, that to me that one looks like a crystal ball with sort of diffraction of light, different colors passing through it. But that's just interpretation. It's got filaments inside.
Yeah.
Kind of red filaments.
You got all of that oxygen in the center.
Mm-hmm.
How did it get the name dumbbell? Well, someone decided that was a dumbbell.
The shape.
And I think it looks more like an apple corn. I think an apple corn nebula is a more appropriate name. It's actually one of the names that is attributed to it.
No, I think I'm going to rename it and call it the Hourglass Nebula, though.
Yeah, apple core, Diabolo, dumbbell.
Diablo, yeah.
Yeah, I think this is more of an apple core because I mean, it does look like an apple core.
Yeah, kind of a red, delicious apple on the outside.
Yeah.
And an icy turquoise interior.
In the old black and white photos, it looked like an old-fashioned dumbbell weight. Okay.
Yeah.
Well, yeah, that's a very long.
Yeah, in the black and white. Okay, man, Fred, you are the historian here. Okay.
That's old. That name. So the name is older than me.
Yeah. Okay.
Yeah. Okay. Yeah. So this is where we're gonna end it tonight.
Okay. Well, if anybody has any comments, shoot them to us. We really appreciate everybody, setting your alarm clock, getting up from your nap, and and your glass of wine or whatever. You're pausing your movie to be with us and to enjoy the sky as seen from Julian here.
Yeah.
So if you have never seen the sky in Julian, come up. Or if you live in some other part of the country or the world, find out what the nearest place is where you can get to a dark sky. Bring your binoculars or amateur astronomy friend with a telescope and have a ball.
Yeah.
Okay? All right, everybody. Take care. Stay safe. Good night. And thank you all.
All right. Bye.
Bye. Okay, click up there.